Start the recording. Okay, so welcome everybody to the last session of the training program for this year.
Thank you.
You're welcome. You're welcome. So I started the recording. So this is going to be on YouTube, on the same YouTube channel with all of the other videos. And I think going forward for the rest of the 5-year program, I'm going to post everything on YouTube. So we'll all be there on the YouTube channel anytime you need to see something. I think that's better than sending the videos one by one on the chat. Okay, so again, welcome to everybody. Thank you for all your participation so far this semester. And I think maybe before we get into the math, I want to take a little bit of time to just do a summation for the semester and give some thank yous to various people and talk about what's going to happen next for the resumption of the program and everything we're going to do after that. So first of all, I just want to start with some very important thank yous to all of the organizers here. So first, thank you, of course, to the teachers for participating, for your attention in a great year. Without you, there's no program. So I thank you very deeply for coming week after week to this program. I think the attendance has really been excellent this year, better than last year. And so I appreciate you logging in every week to participate and enhance the program. So thank you very much to the teachers. I think we can give a little round of applause to everybody. Okay. And so secondly, I want to thank people who have helped organize the program. So in particular to Sange, who I think is not logged on right now, but hopefully she'll log on later, and to Mr. Brople, and to Abraham Jabate, and Miata Tarpe, who has done some work when Sange hasn't been able to be here in terms of all of the recordings. So thank you all again to be able to organize this. There is no way that I could organize this by myself from the United States, and it's important to have people in Liberia doing the organization. So I want to thank you all again for all of your fantastic organizational efforts. Okay, so I just want to recognize and appreciate all of you. Okay, and then I also want to thank some organizations that have been supportive of the program. So the organization, the Liberian Ministry of Education, which has helped do everything on the ground in Liberia. The National Science Foundation, this is of the United States. The National Science Foundation is ultimately who provides the funding for this program. So all of the money for the data comes from the United States government through the United States National Science Foundation. So I want to give the NSF a special recognition for this. I want to thank my institution, Baruch College, and the City University of New York for supporting me in this program. And lastly, I want to thank the I Help Liberia project, without whose support none of this would have ever started. The I Help Liberia project is why I went to Liberia 3 times in 2011, 2013, and 2017 to run workshops. And I would certainly not be doing any of this if it were not for the inspiration and the support of the I Help Liberia project. Okay, so I wanna thank everybody from these organizations for helping make this program possible. So I want to say something about the certification for this program. So there will be certificates awarded. So certificates of participation will be awarded to all participants in the program for the year. Certificates of completion will be awarded to those who have attended the majority of the sessions. And then certificates of distinction will be awarded to 6 participants whose exceptional effort and class participation, including with submitting homework assignments and with participating in class for the homework assignments, in the view of the organizers, was instrumental in improving the class. So for this term, these participants are Tomas Deli, Gabriel G. Taitu Jr., Prince Nenya, Princeton Nenya, Ed Blamo, and Armstrong Zarwalo. So we want to congratulate all the teachers and a special congratulation to those who will be receiving certificates of distinction. So maybe let's all give a round of applause and appreciation for them. And so the certificates, I'm going to print them out. I'm going to show you basically what they're going to look like. This is just a template. It has my name on it instead of your name. But let me show you the template for what the certificates will look like. So if everybody can see this, this is roughly what the certificates will look like. I need to get the correct name of the Liberian minister who's going to be signing the certificate. And in this area here, there will be a seal for the certificate for those who have received certificate of completion or certificate of distinction. So these will all be printed out here and sent to Liberia with the next person that we know who's going there, so that they can be signed by the ministry, and then they'll be available for collection once they're signed. So you will get a physical certificate, not just a computer file. But it may take a couple of weeks for them to all get into Liberia. Okay, so I just wanted to give you a preview of what they'll look like, and then in this area here, there will be a golden seal as well. Okay, so let me stop that share, and let me go back to broadcast this. I need to share my screen again. Okay. Right. Okay. Okay, so this should be on now. Okay, great. So thank you again to everybody who's participated, and make sure that you send your name with the correct spelling to the WhatsApp chat so that we can write it correctly on the certificates. I had a couple of mistakes last year, and I just want to make sure that I'm getting everybody's name correct for the certificates. Rufus, do you have a question? No, okay, hands just raised. Okay, and so I want to talk a little bit about the future. So what's the future of the program? So there's maybe a couple of things that I want to do. So number one, maybe the most important, is that I will send out a survey where you can give feedback about what improvements you'd like to see made to the program next year, as well as which topics you would like to see. And particularly helpful to me is if you can say, is the material too advanced? Is it too fast? Is it too slow? Is there a topic that you want to see? Is there something that you think you need help on? So I'll send out a survey onto the WhatsApp chat list with a form that you can fill out. And the feedback is extremely important to me. So I hope as many of you will take some time to fill out the survey as possible. So question number two that I want to say is, I'm going to be taking a leave of absence from teaching when my daughter is born. So I'm going to be taking a leave of absence from teaching for spring 2023. And so class will resume, or it's not really resume, but class will resume, or I should say restart, with a new topic. And the new topic as of now is undecided. That will depend partly on your feedback. So class will resume and restart with a new topic, probably around August. And probably around August of 2023. So that's when the class will resume, but I will still be on the WhatsApp chat. So if any of the teachers want to have mathematical discussions or anything like that on the WhatsApp chat, then I'm certainly there to contribute and to answer questions and to try to send resources. Okay, but there will be no regular program for spring of 2023. And then the last number three that I want to talk about also is the WITS math competition. And I don't want to say too much about it now because the details are not really fully known. We don't even know what the dates are yet. But this is competition for high school students, and it's run out of South Africa. And last year, I think we had 12 high schools participating or 10 high schools participating. So, there will be more information later, over the WhatsApp chat. And as well as from Sange Freeman and Charles Brobla. Okay, so they'll both have more information for you if you are interested in being a coach of your high school team for the high school students who would participate in the competition. Okay, and I can send, old competitions for preparation, but I'll say something more. We don't know the dates on this, by the way, but the dates, it's going to be either in March, or in May. So we'll see what the preparation is for that, but I'll give you more information about that later. Okay, and hopefully we will have the certificates to you well before March and May. I just have to coordinate with Mr. Randolph to figure out who's going to deliver them to Liberia, because I'll have them ready on my end in about a week. And then after that, it's just a question of getting them to Liberia and getting them signed by the correct people and then distributing them. Okay. So, okay. Any questions about administrative stuff?
Yes.
Yes, Marcus.
Yeah, thank you so much. I just want to appreciate you for what you are doing, and to the organizer of this unique, educational platform that is actually impacting on us. Yeah, I just want to applaud you for your commitment, being in time, and Mana Sange, thanks a lot for the distribution. Sometimes I lost phone last year two times. So it was either the two sessions I didn't attend it, and she see reason I was still from the program. And last year I attended the program, I was awarded a certificate completion, and also part of this year. So what I want to say, you did mention about the to resume. You said August. Well, that would be August. So I want you to make the clarity on the other semester that will resume.
Yeah, I mean, so we will. I don't know what date exactly we will resume, but there will be ample advance notice on the WhatsApp chat. So just stay on the WhatsApp chat, and all further notices for resuming. I mean, certainly it will definitely be, if you would like to participate again, you are welcome to continue in the program. So yeah, the resumption will be, including anybody here who wants. And it will be something new. So it will not be a repeat of what we've done before.
Yeah. Okay. So I think this could be my second time now. So I always love to be part of this, because it also, help us. We as mathematics teachers, help us to do more research. But lastly, my question is concerning the certificate issues. Sometimes last semester was, a bit some mistakes on the names and what have you. I don't know how properly this will be for this semester.
Okay, well, we're going to do our best. The best thing that you can do to make sure that there's no mistake on the names is to make sure that you respond to the WhatsApp chat and you just write your name with the correct spelling, and you include, and you say something like "for certificate." So for certificate, and then write your name, and then I will have it. And if you respond to that, then I will have you, and then I'll also be looking at the attendance sheet. So even if somebody doesn't respond, I should be able to get the certificate correct. But the best thing you can do to make sure that everything is correct is to write on the WhatsApp chat with your name and certificate.
Professor, when do we expect the certificate?
I would hope. I have to confer with Mr. Randolph, so don't take anything as what's definite. But in 1 week, I will have the certificates done and printed on my end. Then somebody has to go to Liberia. I think Mr. Randolph knows somebody who is going soon, but I don't want to say the dates for that. Once this person goes, it should get signed by the ministry quickly. And so I would hopefully expect distribution in about a month. but I need to confirm with Mr. Randolph that that we're actually going to get somebody to Liberia in that time. So actually, Mr. Randolph, do you have a guess as to when we're going to be able to deliver the certificates to Liberia?
Okay. Okay. So,
Mr. Randolph, are you there?
last
Are you there? Sorry, I'm Mr. Randolph. Can you hear me? Okay, he's here in the meeting, but I guess he's not able to hear right now. So, but I would hope that it will not take very long, and we will keep you updated when they're getting shipped and when they're getting signed.
I'm going to be sending it as soon as possible, and by the middle of February, it will be in. By the middle of February, we should be getting it. Okay? Did you get that? Dr. Arbers.
Yeah, I got that. Yeah, that makes sense.
Okay.
Yeah, and I will have them ready on my end by the end of next week. So by January 27th, the certificates will be ready on my end.
And as soon as I get it, we'll inform the teachers through the WhatsApp that the certificates are in, and we will call them at the ministry and we'll do the distribution. And I'm hoping that they be at the ministry so they can get to know each other physically and get to meet each other and probably gossip about me and you and, and share with each other how well they like the program. So I'm hoping that will happen. And hopefully we can have some food for them on that day too. Okay? Water and food.
Great. Yes. So sorry, yes. Today is the last day of class for now.
Can we go into the class? I'm anxious to really, maybe at the end we can say but I would like for us to finish up the lesson for this semester, please.
Okay. I think that sounds good. And we can do more about this afterward. Okay, great. So let's just go back. I have, one more topic I want to do today. So since we took a little bit of time, so I want to just go quickly over the homework problems, right? The laptop, I know nothing about this. I didn't write anything about this. We can discuss it afterward. So the first question is, what is the area of the parallelogram spanned by 2, 4, and 1 minus 5? So if we remember here, we know that the area of the parallelogram is just given by a determinant. Okay. Yeah. Okay. Okay, so with the W, thank you. You put that in the WhatsApp when you respond. Okay. So the area of the parallelogram. Okay, so sorry. Let me mute everybody. Okay, so Princeton has the answer -10. So what we remember is the area of the parallelogram is equal to the absolute value of the determinant of the matrix given by the vectors. So where the first column is 2, 4, and the second column is 1 minus 5. And so Princeton says, if you do this, we get 2 times -5 minus 1 times 4. Right. So if we get this, what do we get? 2 times -5 minus 1 times 4. This is -10 minus 4. And this is going to be equal, but it's absolute values everywhere, right? So absolute value of -10 minus 4, which is the absolute value of -14, which is equal to 14, right? Because an area can't be negative. Okay, so 14 is what we get for the area of this parallelogram, and it requires no drawing and no geometry. You just have to do this calculation and you get the area right away. Okay. Okay, so so any questions on this problem? You just have to do the determinant and that gives you the area. And maybe I should just draw a picture here, right?
Yeah.
Yes, question.
Yeah.
Prince.
Yeah, but Andrew.
Yes.
Yeah, because of the absolute value, because the negative 10, negative 4, you add again negative 14. So it's because of the absolute value coming out of the absolute value, why we saw it to positive 14, right?
Exactly, yeah. The absolute value is what forces it to become positive. Okay, yeah, it's exactly because of the absolute value. Okay, you're welcome. Okay, other questions?
Hello?
Hello, yes, Tomas.
Is it possible to do the same thing with hello?
Yes, hello, yeah. Yep. Yes, Tomas, hello.
Is it possible to do it with a 3-dimension?
You mean using the cross product?
Yeah.
Yeah, so maybe I don't understand the question. You mean with the 3-dimensional determinant formula or using the cross product?
I'm talking about X, Y, Z.
Oh, yes, right. So we had this formula. So this wasn't the problem, but we had this formula that if you have 3 vectors like A, B, C, D, E, F, and G, H, I, then they form, and I don't want to spend too much time on this, but they form what's called a parallelepiped, which is a 3-dimensional shape. And then its volume of this 3-dimensional shape is equal to the absolute value of the determinant of the matrix that has the vectors as the columns. So A, B, C, D, E, F, and G, H, I. Yeah. So this formula does work in 3 dimensions, but we don't need it. We don't need it to answer this question.
I just wanted to know that's all. Thank you. Thank you very much.
Great. You're welcome. Okay, so let's move on because for time. So I want to solve and I'm just going to do the homework problems because I want to make sure that we're able to finish in our time. So the second question is solve the system of equations using matrices. So everybody can solve the system of equations using substitution or elimination, but what we've seen is that we can also do this using matrices, right? So I can write this system as A V equals B, with A is my matrix of coefficients. So it's 1, -4, 2, 3, right? This is the matrix of the coefficients. I have a 1, a -4, a 2, and a 3. And then B is equal to the right-hand side. So it's just the vector 1 - 6. And so what we saw is that the solution, and here, by the way, V is just my variable vector. V is just X, Y. And so the solution, what we saw is that we can multiply both sides by A inverse. So we get that V is equal to A inverse B. And A inverse we can calculate because this matrix is a 2x2 matrix. So we can calculate its inverse. Well, here I have 3. The determinant is 3 minus -8. So that's 3 plus 8, which is 11. So we have 1 over 3 minus -8 times the inverse, which is 3, 1, 4, and -2. And then we multiply that by B, which is 1 and -6, right? So this is A inverse, and this is B. What do we get? Okay. And so in this case, what do we have? We have that this is 1/11 times, well, if you multiply this matrix out, we have in the top row, we get 3 times -6 plus 4 times 1. So that's negative 18 plus 4, so that's negative 14. And then for the bottom one, we have minus 2 times 1 plus 1 times minus 6. So that's minus 8. And so the solution is that x is equal to negative 14 elevenths and y is equal to negative 8 elevenths. Okay. Although, wait a minute, this, I feel like I did something wrong. Did I do something wrong here? Because this answer doesn't look like it checks correctly. So let me check my math. I think I made a mistake somewhere. Does somebody see the mistake? Yes, Gabriel?
Yeah.
Yes.
What we should have done was first 3 times 1
Yes.
and 4 times minus 6.
4 times minus 6. Oh, right, of course. That's going to be 3. Thank you. So that's 3 times 1, and then that's negative 21, not negative 14. Yeah. All right, thank you for the fix here. Negative 21 instead of negative 14, and so we get that x is equal to negative 21 over 11, and y equals negative 8 over 11. That is correct. Great. Thank you so much for fixing that. Okay, so negative 21 over 11 and negative 8 over 11. Okay, any questions on this? And the check I'm going to leave as an exercise. So you can check by plugging in. You can do this on your own. Okay, but if you just plug in negative 21 elevenths for x and negative 8 elevenths for y, then you'll get the correct answers. Okay, great. Okay, so homework problem number 3. So in this problem, I tell you that the inverse of the matrix 1, 2, 1, 0, 1, 1, 1, 3, 1 is 2 minus 1 minus 1 minus 1, 0, 1 and 1, 1 minus 1. So I'm just telling you what the inverse is. I haven't told you in general how to find the inverse of a 3 by 3 matrix. There is a process for this, but we didn't have enough time this semester to do it. So I'm just going to tell you the answer. So the question is, can you use that to solve the system of equations that I write here? Right? X plus 2y plus z equals 5, y plus z equals 2, and x plus 3y plus z equals 7. Well, again, the idea is the same as what we have over here, right? We want to write the system as AV equals B, and then our solution, our V vector for variables, is just A inverse times B. So here, what do we have? This is just AV equals B with A is the coefficient matrix, which is exactly this matrix 1, 2, 1, 0, 1, 1, 1, 3, 1. V is our variable vector, which in this case is 3-dimensional. So we have x, y, z. And B is our vector of constants, the right-hand side, which is 5, 2, minus 7. So the solution is going to be V equals A inverse times B, which is, well, I told you what the inverse is, right? If this is the matrix A, then this here is the matrix A inverse. So we're going to use V equals A inverse B, which is 2 minus 1 minus 1 minus 1, 0, 1, 1, 1 minus 1, and then times 5, 2, 7.
Minus 7.
Minus 7, thank you. Minus 7. Yes. 5, 2 minus 7. And now to do that, let me just do this carefully so that I don't make another mistake. We'll use the column method. So I'll do 5 times the first column plus 2 times the second column minus 7 times the third column. Right, so this is 5 times 2 minus 1, 1, plus 2 times minus 1, 0, 1, and then minus 7 times minus 1, 1, minus 1. And so this is the same thing as 10 minus 5, 5, plus minus 2, 0, 2, and then plus 7 minus 7, 7. And when you add this all together, we end up getting 15 minus 12, 14. And that is the correct answer. So 15 minus 12, 14. Okay. So this way, of course, you can also solve this with elimination. And what we talk about for the rest of today will be a kind of good way of doing elimination, but you can also do it with these matrix inversions, and you get 15 minus 12, 14, which, I mean, I guess really we should write the answer. What that means is that x equals 15, y equals minus 12, and z equals 14, right? This is the answer. And again, you can plug them in if you want to check your answer. For instance, for the second equation, we get that minus 12 plus 14 equals 2. So that checks out. For the first equation, we would have 15 plus 2 times minus 12. So that's 15 minus 24, which is minus 9, and then plus 14 equals 5. So that's good. And you can also check the third equation on your own that that's going to work. Okay. Yeah, so this is, well, the elimination method we're going to talk about a little bit later. What we did here is the matrix method. This is the matrix inversion method. So what we're going to do is a kind of streamlined way of doing the elimination method. That's going to be the last topic that we do today. But before that, any questions on this problem?
Hello, yeah.
Please review the answer for Y again. Yes. Okay. Hello. Well, I got a question from William Boandolo on the thing. Yeah. So please review the Prince question. Does somebody have a question?
Yeah.
Prince,
What I want to know is, question. And with the system equation, you saw with simultaneous with elimination and substitution. With the simultaneous equation, we saw with the substitution and data elimination method as well as the way so we saw with the same method we get the same answer. That's what I want to know.
Yeah, so if I'm understanding the question correctly, if you solve it
if we use a substitution and data the elimination method, why we use a matrix here, we get the same answer.
Yes, it will be the same answer because whatever answer you get, it has to be the solution to this system, right? It always has to check out and make the answers work. So it is true, no matter what method you use, you will always get this answer. And in fact, what we're going to do is use a kind of elimination method in the end of this class, and we're going to show that we get the same answer. So yes, it will always be the same answer. So William Boandolo, the solution for y is just it's just going to be whatever the second entry in this vector is. So the first entry is 10 minus 2 plus 7, so it's going to be 15, that's x. The second entry is minus 5 plus 0 plus minus 7, so that's going to be minus 12, that's our y. And the third entry is 5 plus 2 plus 7, that's going to be 14, that's going to be our z. Okay. All right, any other questions on this problem?
Thank you for the steps taking.
Okay, great. Thank you, Gabriel.
While we been learning all the time,
okay.
we used to say that 2 times 5 plus minus times 2 plus minus 1 times minus 7. And we add we simplify and get our first column value. For the new method, I see from you, it is quite encouraging, and I am happy to learn it.
Sure, yeah, they're both equivalent methods. You can do whichever one you like better, right? So, yeah, they're both fine.
When I was doing this, plenty students have problems with the instructor at the time because while I just explain what we used to do, but students will get confused. But I think if we can learn this and introduce this to our students, I think this will be better.
Okay,
where
good.
Where you took the first column and multiply by the first column, and you took the second column and multiply by the second column as well. It is not by, it is encouraging. Actually, I'm in love with this.
Okay, great.
Thank
Yeah,
you for
I happen to like this method also. I try to do both just so that everybody is practiced with both, but I like this method as well. So I'm glad you like it too. Yes.
It is quite easier.
Okay, good. I'm glad you find it so.
With this, it will not give many students hard time. At the time I was in the University of Labrador, when our teacher introduced it, when we were doing Econ 319, students have problem with. For me, I never had a problem with it, but many students have problems because they started to complain on how would they be. But if I'm teaching my student now, I will check all the method I have learned before and then introduce this to my students.
Okay, great. All right.
Thank you.
Glad that will work. So let's move on so that we can get to the new topic. But thank you for that. I'm glad it will help. Okay, so what's the method for? So many of you are used to elimination. So one of the annoying things about the elimination method is that you have to write a lot. You have to write out your systems of equations and write out your variables. And every time you do an operation, you have to write out the system again. Okay, so a shorthand for writing down the systems of equations is if I have a system that looks like this, I can write down the following matrix which represents the system. So it's just all of the coefficients here, right? This is just the coefficient matrix. And this over here is just the constants. So I write down, it's really a 3x4 matrix. I'm putting a bar here just to separate the coefficients from the constants. But if you don't want to put the bar there, you don't have to. It doesn't really mean anything. It's just to show you that the coefficients are on one side and the constants are on the other side. And so certainly this matrix contains all of the information in the system of equations. So what I think of is that the first column is my x column, the second column is my y column, the third column is my z column, and the fourth column is my constants column. Right. So what are things that we do when we do elimination? Well, when solving a system by elimination, here are some of the steps that you can take, right? So you can certainly take an equation and multiply it by a scalar. You wouldn't multiply it by 0 because that would just give you 0 equals 0. But you can multiply it by anything else. If you need to, over here, I might decide, oh, I want to double this equation and subtract it from this equation so that the two y's would cancel each other out. So I can certainly multiply any equation by a non-zero scalar, by some number other than 0. The other major thing we do in elimination is we either add or subtract a multiple of one equation from another equation, right? This is like the main step we do when we're doing elimination. We're adding 2 together, or we're subtracting 2, or we're multiplying some equation by 3 and then subtracting it from the other one, and so on. So we can add or subtract a multiple of one equation from another. Or the last thing is that we can switch the order in which we write 2 equations, right? So we can switch, if I wrote my equations 1, 2, and 3, I can put the bottom one on the top, right? If that makes things easier, I can certainly do that. And the important observation is that none of the above procedures changes the solution to the system of equations. Right? Anytime I do this, I multiply an equation by a scalar, or I add or subtract the equations from each other. It's never changing the solution set, right? The solution set is staying the same. That's exactly why we do these steps. We do them to simplify and eliminate, and then ultimately at the end, we come up with a solution. We have a new system of equations that's much easier, and we can come up with the solution for that. Okay? So none of these procedures changes the solution to the system of equations. So what can we do instead with elimination? Well, as a shorthand, we can apply these operations above to just the matrix representing a system of equations. So instead of saying multiply an equation by a non-zero scalar, instead we can multiply a row by a non-zero scalar. Right? And what are the rows, right? these are each my rows. This row represents the equation x plus 2y plus z equals 5. This row represents 0x plus y plus, oh, this is a typo, sorry. This should be a 1 over here, right? Yeah, this is a typo, sorry. This should be a 1. So this represents 0x plus y plus z equals 2. And this represents x plus 3y plus z equals minus 7, right? So if I wanted to multiply this equation by 2, that's the same thing as multiplying this row by 2, right? So instead of multiplying an equation by a non-zero scalar, we can just multiply a row by a non-zero scalar. It's the same thing. And now instead of adding or subtracting a multiple of one equation from another, we can just add or subtract a multiple of one row from another. And instead of switching the order that we write two equations, we can always just switch the order in which we write two rows. And if we do this correctly, we can simplify the system to the point that we can just read off the solution. And this is a process which is called Gaussian elimination. And each time we do one of these steps, it's called a row operation. Okay, so it's the same steps that you do when you solve a system by elimination, but instead of writing out all the equations, you're just writing out this matrix and you're just doing solutions by acting on the rows, by doing things to the rows. And what happens when you do this is that you have to do a lot less writing, but you get the exact same information. So as an example, I want to solve this system using this new method, right? So this Gaussian elimination using just the matrices. So what is this? So again, I have my typo here. This should be a 1. So what is this? Okay, so here's what we have. So we have this matrix where this represents the coefficients and this represents the constants. And I want to perform these row operations to simplify the system. And what are row operations? Again, it's these three things. We can multiply a row by a scalar. We can add or subtract a multiple of one row from another. And we can always switch the order in which we write two rows. Okay, so let's just do this. Oh, sorry, Ernest, is there a question? I see the hand raised. Okay. All right, so let's do this. I'm going to write down the matrix 1, 2, 1, 0, 1, 1, 1, 3, 1, 5, 2, 7. And so for elimination, what I want to do is get as many zeros in the matrix, in the coefficient matrix as possible, because zeros in the coefficient matrix correspond to eliminating variables. So what I'm going to do is I'm going to subtract the top row from the bottom row.
Hello, sir.
Hello, yes, Tomas?
Hello?
Yes, Tomas?
Are we going to?
Yeah,
sorry. Oh, sorry. Wait, sorry. I think two people are asking a question.
Yeah,
Prince, yeah? Sorry, I'm not getting you. Prince, yeah.
This 7, the 5, 2, 7, I think could be -7.
Oh, yes, that is another.
Yeah, the 5,
thank
2,
you.
7,
Thank you.
I
Yes,
think could be
-7. That's right. Thank you. Yeah. Okay. So
for the 5, 2, 7 in a constant, the constant 5, 2, 7.
Right, I fixed it. Right, so it's -7 over here. Right, it should be 5, 2, or is it supposed to be 5, 2? Yeah, 5, 2, -7. Right, yeah. So it's fixed. Okay, let me just mute. Okay. So what do I do? Well, what I'm going to do is I'm going to subtract the top row from the bottom row. That's eliminating this 1. So if I want to notate it, I can call it R3 minus R1, right? I'm taking the third row and I'm subtracting the first row. So what I do is I write out the system again, 1, 2, 1, 5, 0, 1, 1, 2, but now I subtract the top row from the bottom row. So in this case, I get 1, 3, 1 minus 1, 2, 1. This is going to be 0 because it's 1 minus 1. And then 1, which is 3 minus 2, and then 0, which is 1 minus 1. So 0, 1, 0, and then I have -7 minus 5. That's going to be -12. All right, so all that I did was I took this matrix and I took this matrix and I eliminated the this variable from this equation by subtracting the top row from the bottom row. Okay, this is called a row operation. Okay, so, well, the next thing I can do is I can also take this row and subtract it from this row, and that's going to eliminate a variable here also. So what I'm going to do here is I'm going to take R2 and I'm going to subtract R3 from it. So in this case, the first row and the third row are going to stay the same. So 1, 2, 1, 5 and 0, 1, 0 minus 12. But now I subtract the third row from the second row. So I'm going to have 0 minus 0 is 0, 1 minus 1 is 0, and 1 minus 0 is 1. So I'm going to have 0, 0, 1, and then here I have 2 minus 12, and so that's going to be 14. Okay. You with me so far? I just did 2 of these row operations where I subtracted one row from another. And I'm allowed to do that. That doesn't change the solutions to the system of equations. So lastly, what I want to do is eliminate as many non-zero elements as possible, right? So I want to eliminate here the 2 and I want to eliminate the 1. So how can I eliminate this 2? Well, I can subtract 2 times the bottom row from the top row, right? I can subtract 2 times the bottom row from the top row.
So it can be R1.
Yeah, so R1 minus
R3.
2 R3, right? Because I want to subtract 2 times it from this one. And so what do I get? Well, the bottom 2 rows don't change, 0, 1, 0, and this is 14 minus 12. And now here I have the top one, so 1 minus 2 times 0 is 1, 2 minus 2 times 1 is 0, and 1 minus 2 times 0 is 1. And here I have 5 minus 2 times minus 12. So that's 5 minus 24, which is 5 plus 24. So this is going to be 29. And then lastly, to eliminate this last, the 14 here in the question I see was because we're doing R2 minus R3. So here we get 2 minus 12. So we're replacing R2 with R2 minus R3. Right, so instead of 2, we have 2 minus 12. That gives you the 14. Okay, so lastly, we want to do this 1, 0, 1. We want to get rid of the 1, so I'm going to subtract the second row from the first row. So I'm going to do R1 minus R2. And what's that going to be? Well, again, the last 2 rows stay the same. So 0, 0, 1, 14. And 0, 1, 0 minus 12. And now I subtract the second row from the first row, and I replace the first row with that. So I have still 1, 0, and then 1 minus 1 is 0, and then 29 minus 14 is 15. So this is 1, 0, 0, 15. Okay. Okay. So what I've done is by doing these row operations, all of these subtractions, I end up with a matrix, especially my coefficient matrix is much simpler, right? I have lots of zeros and only a few ones here. And in particular, each equation only has one non-zero coefficient. And that means that only one variable is getting represented in each equation.
That's right? A beautiful one. That's a beautiful one.
Thank you.
Yes.
Yeah. So what happens with this? Well, we reduced it to, so I guess here I switched 2 rows.
Yes.
You don't have to do this. Yeah. So by the way, let me just switch these 2 rows just so it looks nicer. You don't have to do this, but I can remember one of my row operations is I can switch the order in which I write rows, right? I can switch the order in which I write rows. So for R2 to R3, I'm just switching the order. So I just get 1, 0, 0, 15. 0, 1, 0 minus 12, and 0, 0, 1, 14. Okay, this is just nicer. You know what what I really did was I did these row operations until I got the identity matrix here. And when you have the identity matrix here, you have a very nice system of equations. right? I'm still going to write here x, y, z. So what's my system of equations? Well, we started with this. And again, I keep copying this wrong. I'm sorry, this is a 1. We start with this. And then after performing row operations, we get this. But what is this system of equations? It's just x equals 15, y equals -12, and z equals 14. So that system of equations is easy to solve. This is the answer, right?
That's great. That's great.
Yeah. So, yeah. So this is what's called Gaussian elimination.
Yes, sir.
Yes, Prince, you like this one?
Yeah.
Okay. Yeah.
So it means definitely it will carry on a system equation with say let's say 15, -12, and $14.
Exactly. Yeah. Same answer. Of course, you get the same answer. So the point is, you start with this equation, this system of equations, and instead of writing down, the more you write, the more chance there is to make a mistake, right? But with this, you just write down this matrix, and you're just doing arithmetic, right? You don't even need to know any algebra to do this, right? You're just doing arithmetic. You just take this matrix and you add and subtract rows from each other until you get down to 1, 0, 0. 1, 0, 0, 0, 1, 0, 0, 0, 1. And once you see this, the answer is just right here. You're done, right? So this is the answer. It corresponds to the system and we're done. Okay. Now, how do you do it? Yeah. Oh, yes. Hello. Question?
Hello?
Hello. Yes, Tomas.
Yeah.
Hello?
Thank you very much for this idea. For me personally, I would like to teach the first method to the 12th grader and to the college level. I use the second method.
Yeah, different levels might require different methods. But the good thing is that you're always going to get the same answer no matter what method you use. So if you teach a lot of methods, then some students might like one method and some students might like another method, and either one will let them get the right answer, right? So it's good to know more methods. Charles, do you have a comment?
Thank you.
Yes, I do.
Yes.
Yeah, I would like to thank you for this work, for this problem. But I just would like you to just throw light on. So when you are solving, a matrix using Gaussian elimination, you should always make sure that the diagonal is always 1, or the diagonal,
Right.
And then I wanted you to tell us,
The mean
I
diagonal.
want you to tell us when you have the coefficients and the constants in a matrix, how do we call that?
So this is sometimes called well, I'll go from the beginning. This is sometimes called the augmented matrix.
Very good. Very good.
Okay.
I just wanted you to say that so that
Okay, sure.
the students can pick that up.
Yeah, so when you have the full thing, this is the augmented matrix. And when you have just this part, this is the coefficient matrix. Yeah. And so the point is, as Charles said, right, if you want to get the matrix down to the diagonal with 1s, because when you have it as the diagonal with 1s, then you have x for the first equation, you have only x on the left. And for the second equation, you have only y on the left. And for the third equation, you have only z on the left. So that's why you want to get the identity matrix for the coefficient matrix. You want to get it down to 1s on the diagonal and 0s everywhere else, because then you'll be able to have just x, y, and z. And the good thing about this method is this works for 4 equations and 4 variables, 5 equations and 5 variables, however many you have. This will work. It's not just for 3 by 3. You can do it for 2 or 4 or 5 or whatever. And this method, when computers solve systems of linear equations, this is what they're doing. Okay, they're not doing elimination substitution. They're doing Gaussian elimination. That's kind of the most efficient way for computers to solve systems of equations. Okay, so this is what they're doing. And so it turns out that you can actually write down an algorithm for a systematic procedure that will always tell you which operations to do when, right? So for now, what we did there is kind of trial and error, right? I trial and error. I just kind of did this and I saw, oh, I think if I do this, if I do these operations, it will make the matrix come out nicely. But there is an algorithm that you can follow so that you don't have to do trial and error. Okay, we don't have time right now to discuss this algorithm, but first of all, I'll send a link to it in the chat, but we can also spend some time in the next segment of the class to the next segment of the class to show the algorithm. But this is one of the jumping off points for the study of linear algebra, right? So linear algebra, university level subject, and often what you start with is a serious investigation into this Gaussian or Gauss-Jordan elimination to solve these systems of linear equations. Okay, so I want to just mention, just as a review from this semester, so this term, what have we learned about? Because it's easy to just forget because things happened 3 months ago. So we learned about vectors as arrows in 2- and 3-dimensional space. We learned about vectors as collections of components. We did algebraic operations with vectors. We talked about the relationship between vectors and physics and forces and force diagrams and friction. We talked about dot products and cross products of vectors and also did the relationship with trigonometry. We did some practice with bearing problems. We did algebraic operations with matrices. We talked about geometric matrix vector interactions. So that was these linear transformations, the reflections and the rotations and the dilations. And then we also talked about today and last week about using matrices to solve systems of equations. So it's a nice amount of material, and so we talked about it all, and you have access to all of the videos from earlier on, and definitely going forward, I'm now just going to post everything on YouTube because I think that's the best place to have the videos. I'll post it on YouTube, and I'll try maybe to go post all of the notes on my website so that you can always go back and refer to the note handouts. So I haven't done that yet, but I think I'll do that because I've sent them to the WhatsApp chat, but there's a lot of messages in the WhatsApp chat, and it's hard to go back and find everything. So I think instead what I'll do is I'll post the notes on my website, and I'll send a link to that, and then you'll always be able to look at the notes. I'll do that for this term and for last year. I'll try to just post everything together to the website. So that's some homework for me to post the homework to the website. Okay, so one more time, thank you all for your attention and congratulations on completing the term. I'm going to miss you over the next few months. And I guess for some of the people who came in late and missed some of the thanks that I did at the beginning. So just maybe to repeat, I want to thank Sange and Charles and Abraham and Miata for all of their fantastic organizational efforts for making the program possible. And I also want to thank my organizations, the Liberian Ministry of Education, and also my organizations in the United States that have helped me do this. And the certification will be coming soon. So thank you to everybody, and in particular to the class members who will receive certificates of distinction. And I know I need to put a W here. Lastly, I want to just recall what we're doing in the future. But the most important thing will be the survey. And I'm going to send out the survey next week. And the feedback is really the most important thing because we want to make this program the best possible. And I can guess which topics I think are interesting to teach and which topics might be useful. But what's really useful is to hear from you to say, I want to see this, I want to see that, or this is going too fast, or this is too advanced, or this is too basic. I won't be able to know what's correct unless I get your feedback. So I highly encourage you to send me that feedback. Okay, so thank you again. And that ends the mathematics for this term. And we'll resume in August, but I will be in touch well before then. And we'll also talk, and the certificates, as Mr. Randolph said, we will hopefully get them to you by the middle of February. Questions? Yes, Charles and Miata?
Yes, sir.
Yes.
I want to say you are really a great teacher. We enjoy our time with you, and we hope to be with you again very soon. Thank you so much. God bless you.
All right. Thank you, Miata. I appreciate that.
Okay.
Charles?
Let me
Or Gabriel, yeah.
Let me add my voice to many voices to also appreciate you for the level of things that you have done for us. For me, I'm highly appreciative of your work. Thank you for the time and hope to see you again.
All right, you're welcome. Thank you. Charles, do you have your hand raised?
Hello.
Hello, Francis?
Yeah, Andrew. Hello.
Yes. Yeah, Francis.
I want to say a very big pictures of Neymar Kante, Liberia. Through the process from the start of the
Sorry, we're not getting you very clear.
Hello?
I'm not getting you clear. It's coming in and out.
I'm saying, you getting me now?
No, it's there's some other sound. Hold on, let me just try to mute everybody else. So sorry, if you're not speaking, if you can mute yourself, maybe that will help. Let me just mute everybody who's not speaking. So actually, let me just mute everybody. And now, Francis, turn on your microphone. Maybe that will be better. No, sorry. Okay.
Hello.
Hello, yeah, Francis. I'm not getting you very good.
Are you getting me now, please?
Better, yes, better.
So I say on behalf of the mathematics teacher of Neymar Kante, Liberia, want to appreciate you, inclusive of IHEP Liberia and all partners who have deemed it necessary to maybe move our mind mathematically so that we can be the one bearing the torch of mathematics here. I want to appreciate everyone who has been part of this process. Want to encourage everyone. Let us try to make use out of this program because this program is of necessity. I think what the people are doing for us is more than appreciating them. I want to also say a very big thank you to Mr. Jabate and his IF Liberia team for this initiative. Trust us, we're going to make use out of it. We're going to put it into use. We're going to practicalize it. And we're going to do everything in as much as possible so that we'll be part of the next stage of this thing. And then let us try to encourage our friends. Mostly what we do there is at the point of commencement, we carry on our recruitment. And then after we have submitted our listing of recruited members, some of our members drop along the way without any concrete reason. So if we are doing our recruitment for the next stage, let's talk to our friends. Because you people are making effort so that we all can start this together and end this together. It's a very big thank you. We're going to be part of the process. Just updated in case any whatsoever range you can be part of. I want to say thank you to the Ministry for Education members, including Man Sanki, and for Interact, for being so supportive towards this program. Once again, a very big thank you on behalf of the IF mathematics teacher. Thank you.
All right, you're most welcome. Thank you for those words. Anything else? Yes. Who's speaking? Sangay. Hello, Sangay. We're not getting you very clear, Sangay.
Yeah, how are you, everyone?
Better, yes.
Hello?
Hello, yes, better.
Yes, I want to thank you and the entire class for this session, most especially you and the IF Liberia team for this class. You know, it's very rewarding. And for the participants, without you, wouldn't have been successful. We thank you for your participation. and we look forward to see you for next term. Andrew, we don't know how to say thank you. Just you and the iHelp Library want to just appreciate you for all that you have done throughout this time, your busy schedule, taking it off your finances to make sure people get data to join the class. It has been amazing. So I want to say thank you for everything.
All right, you're most welcome. I really appreciate all of your effort in organizing the program, and everybody for just coming, for showing up every week, so that this is a solid program and it can keep getting better. So it's succeeded beyond what I could have imagined at the beginning. So, and I thank all of your tenacity and dedication for that.
Hello.
Hello. Yes, Tomas.
I would like to say thank you to the HAHEP Liberia team. Thank you to you, Professor Obos. And I have a recommendation.
Mm-hmm.
I would like for the coming semester to ask to Masange to try to reach to Nima County. The math competition we needed. Last semester, I tried my best to put some students together. And at last time, I got to know that the math competition could not reach to Nima County. So this time around, I would like for this math competition to reach to Nima County. One more again, thank you very much.
All right, thank you. Yeah, this time,
Yeah, okay.
I some of this I must say is my fault last time, because I didn't do things in advance enough. With I need to work more in advance to figure out exactly the expenses and what our budget is and how we can make the expenses reasonable for all of the participants. Of course, there's no expense to actually participate in the competition itself. But there are, of course, to get everybody together, and transportation and food requires some expense. So I'm going to try to do a better job in advance this time, so that we know exactly how much capacity we have to fund participation and to do everything that we can in order to get the participation to be as wide as possible.
Yeah. Andrew?
Yes, Charles.
Yes. Once again, I would like to thank you for this great work you are doing. In fact, for this semester, the topic that you covered, these are difficult topics that most of our teachers find kind of evade. They evade most of the topics. And I want to thank you in a special way for covering these topics. And I just pray that the teachers will kind of make good use of what you have taught us, especially for, Gus Jordan, for my area, electrical. We use that a whole lot to analyze circuits.
Mm-hmm.
When you're dealing with circuits, you have several branches, so you can have multiple equations.
Mm-hmm.
You can have 3, 4, 5, 6, 7, equations, and then we use Gaussian Jordan, elimination to kind of solve these problems. And so once again, I would like to thank you for this great work. Knowledge is power. As people acquire knowledge, they gain more power intellectually. And I pray that our teachers will make good use of it. Thank you.
All right, you're most welcome. Okay, so anybody else?
Yeah, hello, sir.
Okay.
Yes.
Prince, sorry. Yes.
Hello?
Hello, yes.
Yes, so, okay, somebody, let me get a question, chance.
Yeah, as I was speaking,
Mm-hmm.
I would like to appreciate you and Dalo our mother, Sanjay, and our Mr. Randolph for the unique program you brought to us. Thank you so much because this is knowledge that we are gaining from you people. And for sure, knowledge cannot be paid for. So taking your own time upon yourself, teaching all is wonderful thing. So once again, I would like to say thank you. And I appealed for the next semester, we should include like some geometric terms into it, more geometric. So at least we can make thought and then we ourselves can do the same in the classroom. Thank you once again. I appreciate it.
Okay, you're welcome. Okay, Sanjay?
I just want to say for those who on this platform are teaching in different schools, the competition is for you to sign up, make use of it. It will help you to take global competition because it's a competition that people all over the world are taking part in. So expose your children to global competition, sign up for it. When the time comes, we'll send a message in the platform for you to sign up, and we'll reach out to your school and give you information you need to prepare your students. And also, same thing, Mr. Rana, he's the brand thing, and without him, we wouldn't have gotten connected with all these good people who think to visit Liberia, taking up their time. So I want to say thank you, Mr. Rana, for your sacrificial you have been doing, and with this kind of rewarding program. So I appreciate you so highly. Thank you everyone for being there for this time. And let me not forget Abraham. Abraham and I have been ready taking Abraham Miata. We have been coordination to make sure that this program was realized. Thank you for the work and for everything we've been doing together to make sure.
Thank you. Thank you, Alma. He was the one who introduced me to the program.
Okay.
I'm happy to be in your midst.
Yeah, where's Abraham? I don't see where he is if he's still on right now. Okay, so hopefully when there is the certification, we'll be able to get everybody together once more and maybe in person, so everybody can meet each other.
Andrew.
Yes, Mr. Randolph.
I would like for us to try something.
Okay.
You're going to, okay, math teachers